In this video, I will be explaining you a derivation of equation of motion of simple pendulum. Okay. So here you can see a figure. You have to draw this figure in the beginning of this derivation. So this is x-axis, this is y-axis. This is the two axis meeting point is O, origin, and here this is an extensible string and having length L. At the end of the string there is a mass M. Okay, the string is moving. This is an equilibrium position. Okay, when there is no any motion, then the string will be like this. When there is a motion, it goes on like this. Okay, so here in this figure, this makes an angle. This string and this axis makes an angle theta. Okay, so let's start the derivation. A pendulum consisting of a point mass M. There is a pendulum, and the pendulum there is a mass M, and this mass M is suspended by an inextensible string of length L. Okay, this mass is suspended. It means hanging by an inextensible string. The string is non-elastic. Okay, it's non-extensible string and it is having length L. Okay, the position of the mass is completely determined by the angle theta. Okay, the position of the mass is determined by the angle theta, right, between the deflected and equilibrium position of the string. This is the equilibrium position, this is the deflected position. Okay, this and this equilibrium position of the string and the deflected position of the string determines the angle theta. That is what they are mean by this sentence. Now here, then you have to write for simple pendulum, you have to know the formula of kinetic energy. Okay, so here you can find for simple pendulum the kinetic energy is denoted by capital T. Okay, is given by capital T is equal to 1/2 m of L theta dot the whole square. So here in the next step you are giving the square to these two so that you will get this. Okay, if damping is neglected, it means what? Damping means movement is neglected. The work done by the gravity in lifting the mass from its equilibrium position to the position theta is negative. If there is no motion, then the work done the value will be negative and is given by this minus mgl of 1 minus cos theta. And now you are writing the potential energy formula, that is this V is equal to plus mgl of 1 minus cos theta plus constant. Okay, so after this what you are doing is you are using a Lagrange's equation for the conservative system. You are using this formula, and this formula is this equation is the Lagrange's equation for the conservative system. Okay, you are using this. You have to memorize this. D by dt dou t by dou qi dot minus dou t by dou qi plus dou v by dou qi equal to 0. Now what you are doing is in the place of qi you are putting theta. Put qi equal to theta so that you will get this step. Now you are going to substitute the values in this equation. To substitute the values in this equation, you have to know you have to find dou t by dou theta dot dou t by dou theta and dou v by dou theta. So it's not difficult to find these values. The reason is because if you have the value of t, okay, can you see that? If you have the value of t, then easily you can find the value of dou t by dou theta dot, right? You have to, how you can find that? You have to differentiate t, partially differentiate t with respect to theta dot. Here you have a value t, right? From this you can easily find dou t by dou theta dot, right? You have to differentiate this t with respect to theta dot. So when you partially differentiate it with respect to theta dot, you will get this value. And similarly, you have to differentiate t with respect, partially differentiate t with respect to theta so that you will get 0, because for t there is no theta, right? So there is no theta. When you partially differentiate it with respect to theta, you will get 0 because there is no theta. Okay, now you are finding, now you have to find dou v by dou theta, right? You also need this value also to substitute here. So how you can find this? You have to differentiate, partially differentiate with v with respect to theta. Here you have the value of v. You are going to partially differentiate this v with respect to theta. So when you do that, you will get this. Okay, now you will substitute these values in this star. So when you substitute that, you will get this line. Okay, from this, when you you are not partially differentiating this, you are differentiating is this, so that you will get this line. And from here you are dividing it by ml square, so that you will get this. And this is the equation of motion of simple pendulum. Okay, here this derivation comes to an end. Thank you.